Alright, so we have a triangle, we're given the vertices, we have to show its isosceles. So if it's isosceles, two lengths are going to be the same. You can use vectors or you can use interval notation. For example, just AB is fine as well because that's the interval between A and B. So we know that that is the square root of, if we're looking for distance, so we're going to be doing, I'll do 4 minus 2 squared, 2 minus 0 squared, and 6 minus 2 squared. Hopefully I've got those right. So you can see that is going to be 4 plus 2 is 6, so 36, 2 is 4, 4 is 16. Whatever that is. Now, what if I tried AC? Again, here I'm going to go 4 minus 10. So I'm just taking 4 and 10 there. 4 minus 10 squared. I've got 2 minus 2 squared using my y's. And then I've got 6 minus 4 squared there. So here I'm going to get 6, 36. Doesn't matter if it's negative. 4, 16. 2 is 4. Oh, just happened to pick the right side. So let's just make sure it's not equilateral. So if I look at BC, I'm going to get minus 2 minus 10 squared, 0 minus 2 all squared, and 2 minus 4 all squared. So that one hopefully gives me something different. That will be 12 squared, 2 squared, and 2 squared. Yeah, so definitely different. So you can see that AB equals AC, and they don't equal BC. I'll put therefore isosceles. Alright, so it's definitely isosceles. And then we're interested in the exact area of this triangle. So if you think of this triangle, we know it's isosceles. So if I had to make it isosceles, they share an A. So that would be ABC. And if I wanted the area of that, well, I could use area as half the base times the height. If I knew, because it's isosceles, I could do this and find the midpoint. Let's make that M for midpoint. Let's find the midpoint of BC, and then I can find the distance AM. And I already know the distance BC. So for 52, so 152 there. So I already know the base BC is root 152. So I'm just interested in finding AM. Alright, so let's find M first. So to find the midpoint, M, I just have a look at B and C. Remember, I'm just adding and averaging each of the X, Y's, and Z's. So BC, which one's BC? So this is BC here. So 10 minus 2, if I look at the X's, would be 8. So the average of that is 4. Then I've got minus 2 and 0, so the average of that is minus 1. And then I've got 4 and 2, which is 6. The average of that is 3. So the midpoint is 4 minus 1, 3. So sorry about my working here. So if I'm interested in this distance AM, because that's my perpendicular height, that would be the square root of, where's A? Alright, I'll just put A here so I can compare it easily. 4, 2, 6. So 4 minus 4, minus 1 minus 2, which is minus 3, so 3 squared. 3 minus 6 is minus 3, so that's also going to be 3 squared. So I'm going to get the square root of, I could do 9 times 2 and say that's 3 root 2. I could do that, just make it easy. I should actually write my area in terms of those distances. So half times BC, the length BC, times the length AM is what I'm looking for. Alrighty, so here I've got, I'll put these two together. So I've got 3 on 2, root 2. Now I've got 4 times 38 is 152, so that'll be 2 root 38. So those 2's will cancel, and then 38 is 2 19s. So if I just move this up a bit. So what I'm actually going to have here is, I've got that 3, I'll put these together, so I've got 2, and then 38 is 2 19s, so you can see I'm going to get 3 times 2 out the front, and I've still got a root 19, so it's that many square units. So if the question was, what was the question? Just finding the area of that triangle, I'd say 6 root 19 units squared.